Second example for 3a is looking at extending from example 1.16. This time we need to find where that curve is going to meet the tangent for a second time. So to do this we need to firstly derive the function. We've got dy on dx would be equal to 3x squared take 2x. Substituting the point into the equation of the derivative, we would have 3 take 2, which we know is equal to 1. So this point we know that the slope is equal to 1 and we pass through the point 1, 1. What we want to be able to do firstly is find the equation of the tangent. So that would be using y equals mx plus c. To find c we substitute in the coordinates of 1, 1. So c in this case would equal 0. So our tangent equation would be just y equals x. We want to identify where that equates to the original cubic function. So y equals the cubic, which is equal to the linear tangent. Bring everything over to one side. And we have an equation of a cubic. We would use the polynomial solver, which we can find in our graphics calculator. So in the graphics calculator we're looking for the polynomial option. This is a degree of 3 because it's a cubic. And if we go back to our cubic we have coefficients of 1, -1, -1, +1. If we've done this correctly, we should have a repeated root at the x-coordinate of 1, which we used from our original point given. And the second point we've been now given is this second one of -1. So we can go back and our identity is that the curve is going to meet the point at x take 1 squared x plus 1. So therefore x equals -1. And because it's asking to find the point at where it intersects, we can also substitute that in to either the tangent or the original cubic. The easier one here would be the tangent, so y must equal -1 as well. So the point is -1, -1, where this would intersect.